It's always been there. It's always been there. Always been there. All right. Here's what we're going to do today. Today we are going to compare and order rational numbers. Comparing and ordering, you understand. Rational, we're going to get to in just a second. Now, here's what I'm going to say. The first thing that I want to show you, I just want to give you an introduction, okay? An introduction to how you can do this without a calculator. When I say introduction, it means if you have not had this before, you're probably not going to remember it, okay? You're not going to learn it now. In 2 weeks, when we start our, or actually, we got the test on Friday. In 1 week, when we start our fraction chapter, yes! No. Fractions! Yeah. Woo! Yeah. When we start our fraction chapter, we will work more with this, right? Okay, so this is an introduction, okay? But if I want to compare fractions, the denominators have to be the same. The number on the bottom has to be the same. So what I need to look at the smaller number. Kyler, can I multiply 3 by something to get 6? Yeah. What? 2. So if I multiply this by 2, it's going to be 6. If I multiply the top by 2, it's going to be 2. So I've just rewritten this. I've done the backwards of simplifying, right? I'm simplifying in reverse. So as I look at this, the bottom's the same. Just look at the top. Hey, which is bigger, 5 or 2? 5. Genius. So 5/6 is greater than 1/3. Over here, Serena, what do I have to multiply 5 by to get 10? 2. So I'm going to multiply the top by 2, the bottom by 2. This will be 8 over 10. So, which is bigger? Than 9. So 8 is less than 8/10 is less than 9/10. Okay? Now, what do I need to multiply 6 by to get 9? Nothing. Maybe you know the decimal. Okay, maybe you know the decimal, but I don't want to be multiplying by decimals. Okay. Next chapter, we will get there. I will show you how to do this. Okay, it's not too hard, but I'm not going to today. Instead, here's what I want you to do today. Today, I want you to take your calculator and go 6 divided by 9. Because remember, anytime we are comparing and ordering, we want to change it into a decimal or into a normal number. Griffin, what's 6 divided by 9?
0.66666666.
Okay. 0.6 repeating. How about this? 4 divided by 6. Everybody do that in your calculator. 4 divided by 6 is what? 0.6 repeating. Okay, so as we're looking at these are obviously the same. This needs to be equal. Over here. And maybe you can tell just by looking at it. That's awesome. That's where we'd love to get to. Take 15 divided by 21. 15 divided by 21. Kenley, can you tell me when you get that?
0.714285.
Okay. I bet that'll be enough. And now 12 divided by 18. Amy, can you tell me when you have that? .6 repeating. All right, now I want to make sure that everybody understands how to tell which decimal is bigger. Okay. This number over here is 6,666 that I have written down. This number is 714. That does not mean that this number is the bigger one. Okay? That doesn't mean that. Look after the decimal at the first number. 7 is bigger than 6, so 0.714 is greater than 0.6666. All right? Let me change this. Even if this was erased, which is bigger, 0.7 or 0.66? 0.7 is bigger because 7 is bigger than 6. I would like for everybody to do numbers 6 and 7. Okay, Oscar, 24 divided by 32 is what? 0.75. And 36 divided by 48 is 0.75. So this is going to be equal. Haley, what was 8 divided by 11? .72 repeating. How about 10 divided by 13, Ken? What was 10 divided by 13? 0.769. Okay. So now, as I look at these, my 7s are the same. So I need to look at my next digit. 6 is greater than 2. So I've got 8 11ths is less than 10 13ths. If you're doing one like number 9, first look at the whole number. Ignore the fraction. Look at the whole number first. 4s are the same, right? If they're the same, just ignore it and look at the fraction. So over here, number 10, they're the same. Ignore them. Look at the fraction. If number 10 were like this, 8 and 4 ninths, 7 and 2/3, just look at the whole number. 8 is bigger than 7. 8 is greater than 7. So 8 and 4 ninths would be greater than 7 and 2/3. Okay, let's look at these. Comparing percents and ratios and decimals. Number 13. Everybody started. I'll give you a hint in about 30 seconds if you're not sure what to do. Number 13. My first hint is going to be change them to decimals so that you can compare them. The next hint, 8 out of 10. Just means 8 divided by 10. One thing, if you guys hold up your whiteboards, turn them around, I have a lot of trouble seeing. If you just leave them on your desk, I can tell real quick. Okay, now, very important. Remember to change this into a decimal. Jonathan, if I change this to a decimal, which way do I have to slide it? To the left. 2 times to the left. So move it 1, 2. This is going to be 0.50. And 8 divided by 10 was what, Jennifer? 0.80. So, looking at the first number, 5 is less than 8. So, 50% is less than 8 out of 10. Let's try number 16. 1 out of 3 compared to 1.3. I would change those into decimals. The 1 is already a decimal. Number 16. Okay. Just a real quick question. 1 out of 3, is that more or less than 1? 1 out of 3, that's less than 1, right? That's a fraction that's less than 1. 1.3, is that more or less? More. So really, this is one that we should be able to look at and just right now know. This is less than 1, that's more than 1. 1 out of 3 is less than 1.3. If you put this into a decimal, this would be 0.3 repeating. Okay? 0.3 repeating. Okay, let's look at look at the second one. I want to put all of these in order. I've got a fraction, I've got a decimal, I've got a percent. Let's change them all to decimals. Okay? Change them all to decimals. So, first thing, Abby, can you tell me what 7 divided by 8 is? It's not working? Okay, somebody else. Shayla. 0.875. 0.98 is already a decimal. So now let's change this one to a decimal. Bryce, what is this as a decimal? Very good. Change it to a decimal. Slide it to the left. This is going to be 0.985. Now, to compare the order from least to greatest, look at the first number after the decimal. 899. So, obviously the 8 is the smallest one. This one is going to be my first. Now, let's compare these two. First number is 9. Second number is 8. This one does not have a number. This one has a 5. If we run out of decimals, what number would I have to put there? What number? Do you know? Jaylee, do you know what number? 0. Very good. 0. So as I'm doing this, 0 is smaller than 5. So this will be my second, and this will be my third. Okay? Just happen to be in the right order. So, anytime you're putting a number in order, change it to a decimal. Okay? Now, put your whiteboards and markers away and still listen to me because I've got one more thing to say. The next thing we have to do, remember I told you that I was going to tell you what a rational number was? Okay? I'm not going to give you the textbook definition yet. I'll give that to you later. I just want you to be able to identify a rational number. First of all, if I ask you if a number is rational, you are going to say yes. Okay? If I ask if a number is rational, you are going to say yes. Yes. Okay, so I'm thinking of a number. Is it rational?
Yes.
Yes. Mr. Hamilton has a number written on the other side of this board. Is it rational?
Yes.
Mr. Zartman has a number written on his board. Is it rational?
Yes.
Yes. Okay? Every number is rational unless it is a decimal that doesn't stop and does not repeat. Okay? So the only time you get a number that is not rational is if it does not stop and does not repeat. Everything else is rational. Your number that must be a decimal, does not stop, does not repeat. So, the number I'm thinking of, is it rational?
Yes.
Yes. The number that Mr. Hamilton has written, is it rational?
Yes.
Yes. This number, is it rational?
Yes.
Yes. This number, is it rational?
No.
No, because it is a decimal that does not stop and it does not repeat. These 3 dots right here means it continues going on forever. All right? And as you're looking, it does not repeat. There's kind of a pattern there, but it doesn't repeat. How about this one? Give me thumbs up or thumbs down. Remember, every number is rational unless it is a decimal that does not stop and does not repeat. It is rational. Okay? This is a decimal that does not stop, but it does repeat. So this is a rational number. Yes, sir.
I thought it was rational, but just the line on top. You can always put a line on top is rational.
If it repeats, it is rational. Every number is rational unless it does not stop and does not repeat. Okay? Every other number is rational. Okay. I've got a comic for you. It says, like most veterinary students, Darin breezed through chapter 9. All right, so Darin is going to be a vet. Chapter 9 is equine medicine. What's equine? A horse. Equine is a horse, okay? So this is horse medicine. Diagnosis, broken leg. Treatment, shoot it. Diagnosis, infected eye. Treatment, shoot it. Diagnosis, sprained hoof. Shoot it. Runny nose. Shoot it. Fever. Shoot it. All right? You guys have heard that saying, right? Anything wrong with the horse, oh, you got to take it out behind the barn and shoot it, right? Easiest treatment ever. Just shoot it. All right. Here's your assignment. Make sure you notice 8 through 38 even. Okay? So in this first section, it is just even, and then after that, you're doing all of them.